Okay, so these are their exam 1 review slides for spring 2017, stuff like that. So we're going to go over the nomenclature first, and then we'll be dealing with the reactions and things like that in the second half. Okay, so I'm going to go through some of these, right? So with that, so if you have so first one here, right, it's the carboxylic acid, right? So here's that carboxylic acid functionality here. So the first thing you got to do is find the parent chain that contains that carboxylic acid group. So don't forget, you can put those put the dots in where your carbons are. Okay, so with that, so you might as well start here because it's got to include that carboxylic acid, right? So 1, 2, 3, 4, 5, 6, 7, right? So but don't forget to go down the side chains, right? So 1, 2, 3, 4, 5. Okay, so that's going to be your main chain, right? So it's 7 carbons. So you start off with heptane, right? So the base structure, you're going to take off the E and add oic acid. Okay, so now you're going to be doing the side chains, right? So you have a chlorine group here, right? So it becomes chloro, and then you have this methyl group here, so methyl. Okay, so carbon 1 is going to start at the carboxylic acid group. So 1, 2, 3, 4, 5, 6, 7, right? So like that. So the methyl group's hanging off of 4, the chloro's at 5, right? So like that. So for here, so as you assemble the name, right? So it'd be 5 chloro, 4 methyl, right? Because chloro comes from 4 methyl, and then your main chain heptanoic acid. Okay? So like that. So then from here, we're going for the alcohol. So remember, right? So here's your alcohol here, right? So right. So on this carbon, there's no C double bond O that would make it a carboxylic acid. It's just a strain. It's just a regular OH. So put in your carbons, your dots. All right. So again, a parent chain that contains the alcohol group. So 1, 2, 3, 4, 5. Right. But you can also do 1, 2, 3, 4, 5, 6. Right. So like that. So here's the main parent chain. Okay, so be hexane, right? So you take off the E and add the OL, alcohol, the OL for alcohol. Okay, now you are going to have to right. So the side chains, there's really just one side chain. It's the methyl here, but for doing the numbering, right, you gotta let me know where that alcohol group is in the molecule, right? So by that, so is it coming off of 1? Is it coming off 2? Is it coming off 3, 4, wherever? Okay, so with that, so because that does make a difference. So like that. So here you can choose the side, the end closest to where the alcohol is, right? So it's going to end up being, right? So 1, 2, 3, 4, 5, 6, right? So the alcohol is coming off of carbon 3, and the methyl group is coming off of 4. Okay, so when you assemble the name, it's going to be 4-methyl hexane 3-ol, right? So by that, so where's the alcohol? It's at carbon 3, right? But I didn't include this alcohol name. That's what the OL is for. Okay, where's the methyl? It's at carbon 4. Now you could also do the older naming scheme, which is 4-methyl, right? 3-hexanol. Okay, that's perfectly fine too. This is the newer adaptation, but everybody's gonna know what you're talking about with this. Okay, it's just you put the number out front. It's not a big deal. Okay, so for the aldehyde, okay, so again it's gonna be right. So here instead of an OH here, you have just the H. Okay, so you're gonna put in the dots for your carbons, right? So okay, so it ends up being right. So 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, right? So with that, so it's gonna be one of the 6s. So I'm gonna pick this one. It wouldn't really matter if instead you went up there. It's gonna be the same, all right? So 6 carbons, so it becomes hexane, right? You take off the E, and it ends up being. And for the aldehyde, right, you use the Al for aldehyde. Okay, so it becomes hexanal. Okay, so you have the 2 methyl groups for your side chains, right? Right. So with that, and again, this carbon 1 is that where the aldehyde is. So 1, 2, 3, 4, 5, 6. Right. So with that, so it becomes 4-methyl, 5-methyl here. So when you assemble the name, it would be 4,5-dimethyl hexanal. Now you could say 4,5-dimethyl 1-hexanal. Okay, and if you did that, I wouldn't take it off, but this is probably the better name. When you're starting off, it's never a bad idea to go ahead and put that in there, but it is understood that it has to be at 1, right, because the aldehyde has to be at the end. Okay, so with that, so if you want to put it in there when you're starting off, that's fine by me, but do know that you don't need it. Okay, now for ketones, again, you have to have, right, let's put in our dots. That. Okay, so about that. So here, you have the main chain that has the ketone in it, right? So 1, 2, 3, 4, 5, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8. So make sure, it wouldn't matter if it's 1, 2, 3, 4, 5, 6, 7. Well, not that. 2, 3, 4, 5, 6, 7, 8, right? So with that. So you're going to have one of these 8 carbon pieces. They're going to be all the same. Okay, so so 8 carbons, right? Octane. But for a ketone, we take off the E and add ONE. So it's own, not one, but own. Okay, so but that, like most for ketone, right? So a lot of people have a ketone in their medicine cabinet with acetone, right? Acetone, the ONE indicates that it's a ketone group. Okay, so for here, we've got this methyl, and then these 2 independent methyl groups. It's not an ethyl group, but it's it's 2 methyls. Okay, so this side. Oh, and you're gonna have to tell me where that ketone is, right? Is it here? Oh, it's not gonna be here because it's gonna be an aldehyde. So here. Where is it along here? It could be here. Somewhere along in there. Okay, so for here, this side is the closest. The end is closest to the ketone, right? So that becomes 1, so 2, 3, 4, 5, 6, 7, 8. Okay, so it becomes 2 methyl, 6 methyl, 7 methyl. Okay, and the ketone's hanging at carbon 3. So when you put it together, you do 2, 6, 7, 7 tetramethyl. Yeah, I know I put 2 in here. Right, so you just let me know if there's a tetra here. I need 4 numbers, even if they're all the same number. Okay. The other way, octane 3-one, which is saying the ketones at carbon 3. The other way that you could write it would be 2, 6, 7, 7 tetramethyl 3 octanone. That's fine. I'll take either one. So, but again, notice I wrote ketone in here and put it in quotes. That's what this is for. Okay, but we need, let me know where that is. It's a carbon 3. Okay. Now we're going to talk about this a little bit more. But for things like if there is if you have more than one group, there is a priority list, stuff like that. So you do need to know that from the things, right? So for that, so for example, like carboxylic acid is the highest, and then I think esters and amides, aldehyde ketones, and then alcohols. Okay, those are the ones you need to know. Now, if you have an aldehyde, for example, if you have an aldehyde and ketone in there, okay, the aldehyde is going to have the priority. Okay, so we need to figure out a name for this. Okay, so what we did is we said we decided to use the oxo. Okay, so you're going to need on that list. You're also going to need to know what they are, what the groups are when there aren't the priority group. Okay, so the way that they figure this out, right? So if you had a fluorine, right, it becomes fluorine. Right? What do? They take it and it goes to fluoro. Okay, fluoro. Right. So with that chlorine, right? So chlorine, right. Right. So with that, so you take off the N and just add an O. It becomes chloro. Okay, with oxygen, right? They just took oxygen. They took off this giant piece here, and then again, just added O, so it becomes oxo. Go figure. But you name it just like an aldehyde group. It just the ketone becomes an oxo side chain, right? So you put in here, right, like that. Okay, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4. Right now you can have this 1, 2, 3, 4, 5, 6, 7. Okay. However, it doesn't include that aldehyde group, so we can't use it. So that ends up being the main chain, right? So it ends up being right. So we have our oxo group here, and then we have this ethyl. Okay. So the numbering ends up being 1, 2, 3, 4, 5, 6, right? Because carbon 1 of the aldehyde is going to be number 1. So the oxo is at 3 and the ethyl is at 2. Okay, so the ethyl comes first because it's first alphabetically. So it's going to be 2 ethyl, right, 3 oxo, 1, 2, 3, 4, 5, 6. It's going to be hexanal, right? So with that, so I forgot to put that. So C6, right? So the main chain, it's hexane. Take off the E and it becomes hexanal. Okay. So here's our name. Now you could write 1 hexanal, that's fine. I don't mind. So like that. So. Okay. So for amides, Okay, so with that, so what you're going to do is the main chain is going to be on the C double, right? So here's your amide group here. The C double bond O side, the carbon's going away from the C double bond O. That's going to be the main chain. Okay, so 1, 2, 3. All right, so here we go. So here's going to be 1, 2, 3, 4. 1, 2, 3, 4. Okay, so it doesn't matter. So we're going to take just this one. Okay, so we C4 butane. Now for here, you're going to take off the E and just add amide. Okay, it makes sense. Okay, now what's going to happen here for the side chains? Okay, we're going to have this side chain, so methyl. We have this side chain, ethyl, and this side chain, propyl. Now, if there's a hydrogen coming off of that nitrogen, we don't worry about it. Okay, so if there was a hydrogen here instead, so if it looked like, say that, okay, it would just be the ethyl and that's it. We wouldn't list the hydrogen and side chains. If it's not listed, we assume it's a hydrogen. Okay, so like that. So for here we have methyl ethyl propyl. Okay, so if it's off of here, if it's off this part of the side chain, right? So we go 1, 2, 3, 4. It's coming off of 3. Now, if it's coming off the nitrogen, what we do is we say, okay, we're going to say it's instead of using a number, we use N to say it's coming off the nitrogen, right? So it's N ethyl. We have an ethyl group coming off of that nitrogen. We have a propyl group coming off of that nitrogen. Okay, and so when we assemble it, these work just like any other number, right? So it would be ethyl comes first, so N-ethyl, okay, and then methyl comes next because it's next alphabetically, so 3-methyl, okay, N-propyl butanamide or butamide, either one, okay. If say this was methyl-methyl, actually I think the N comes first, although I don't really care which way you do it. So it would be like N3-dimethyl propyl N-propyl butanamide. Okay, so the N's were just like numbers. Okay, stuff like that. So don't treat them no differently. So now the weird one are esters. Okay, so the esters, this is a sort of a legacy of how they were originally created, and they've just never gotten around to fixing it. And to fix it, it would be now they don't care, and it would be too difficult to go back and rename everything. So we're stuck with it. Okay, so here you're going to need to sort of cut this in half and say, okay, we've got the O side and the C double bond O side. So here, what you're going to want to do is you're going to list everything on here. And actually, I did this in here. I'm actually going to put a chlorine here to show you how this works. Okay, so I'm going to put a chlorine here. So we have a 2-carbon group on this side, and you name it like a side chain. Okay, so ethane becomes ethyl. Okay, so that is going to be it. Here, you're going to do, right, 1, 2, 3, 4, right, so with that. So butane, right, becomes, you take off the E and add butanoate. Okay, now there's also this chloro. I added the chloro. Okay, so there's 1, 2, 3, 4, right, so 3 chloro. Okay, so like that. So it ends up being 3-chlorobutanoate. Okay, so that's the C double bond O side. So what you do is you bolt in this out in front of here. There's no mixing and matching at all. Okay, there's no mixing. You say, so even though chloro should come up before, it doesn't. This comes first. So the final name is ethyl 3-chloro butanoate. Okay, so this part always comes first, no matter what it is, and you do not mix it in with the rest of the name. Okay, you name what's out here and then the rest of the name. I cannot emphasize that enough. Okay, so it's not going to be 3-chloroethyl butanoate. Ethyl comes first. So good luck with that. Now, mechanisms to know. Okay, so with that, so for here, right, so with that, so for this one, you're going to get one of these, a hydride or an alkyl shift. So with that, so if you had, say, this one, all right, so HBr, right? Okay, the mechanism, so draw this out. Draw this as a curved arrow mechanism, right? So that's going to be here and here, right? So that attacks there, here, right? Because this has a partial negative. Okay, so that's going to go here, right? So the hydrogen goes on this side, right? Positive charge goes on this side, right? But here we have a secondary carbocation. This hydrogen is going to shift over there, right? So at that, and in doing so, all right. Oh, plus a Br minus. Okay. And in doing so, you're going to put that carbocation there. Now this is going to attack there to make that. Okay, so like that. So what we're doing is we're going from a secondary carbocation to a tertiary carbocation, right? Because this one only has, this carbon here only has 2 carbons attached to it. This carbon has 3, and a tertiary carbocation is going to be a lot more stable. Okay, so like that. So it's going to be not much different than this. Okay, so for these, okay, you're also going to get one of these. Okay, so you get 2 cardinal mechanisms. Okay, so for SN1, right? So okay, so let's say it's bromine plus iodine going to this. Okay, and I say okay, it's an SN2 mechanism, right? So Br minus. Okay, so for SN2, put in your lone pairs here. All right, SN2 all happens in one step, so it's that kick away, and that's it. Okay. Oh, I'm sorry, that was an SN2. For an SN1, right, we're going to start off again with the same product, or same reaction. But now we're doing it under SN1 conditions. Okay, now for this one here, right, the leaving group goes away, and so you end up with that. That's Br minus. Now this is when your nucleophile comes in and attacks to do this. This happens in 2 steps, this happens in 1. Okay. Now for the E2 mechanism, right, so with that, so we're going to have this, right, so it's elimination, right, so I don't know, plus OCH3, methoxide. We're going to make this plus methanol. Okay, so an E2 mechanism, okay, this is where we get, right, so it's going to be over here, right, it's going to grab one of those hydrogens, that's going to collapse down and kick that away. All happens in one step. Okay, the base comes in here, grabs one of these 2 electrons come in and collapse away. This carbon can't have 5 bonds, so it pushes that away. If we're going to run it under E1 conditions, right? You're going to get the same product. Oop. The mechanism is slightly different. Remember with E1, the leaving group goes away. You give that. Now the base comes in, grabs the hydrogen, and that collapses down to make that. Okay, so if you can do these, you just need to do, I'm going to give you one of these. Now, the molecule is going to be a little different, but you need to know, I'm going to give you one of those. I'm going to give you one of these. Okay, so you need to know them. Okay, so for an SN2 mechanism, right, remember, so you're going to have predict the product kind of things, right? So for SN2, right, you're going to have this whole thing swapping for that leaving group. Okay, so the OH comes in here and swaps for that. Okay. Now, for nuclear substitution on a pi bond, right, so this is typically going to be a C double bond O. If you don't have a good leaving group, if you only have carbon-carbon bonds that are formed, okay, so this, you have to remember, that is essentially going to be, wherever that metal is, that's going to be a lone pair that's going to attack there and push that up. Okay, this thing can't collapse down without breaking a carbon-carbon bond, so it's not going to happen, so it's going to start here. Now, if instead, let's say this was an ester, when it got to this point, right, there'd be an oxygen here, we can kick that away, so this collapses back down and pushes out that leaving group here to reform that. Okay, so you have to look, is there a leaving group, is there not? If there's a carbon-carbon bond that you'd have to break, or a carbon-hydrogen bond, you'd have to break in order for this to collapse down to reform the C double bond down. If it's just carbon-carbon and carbon hydrogen bonds, the collapse isn't going to happen. If it's something other than that, then it will. Okay, so this one here, right, remember, wherever that carbon-metal bond is, here, or like right there, these guys are going to assume that this carbon, right, and actually this carbon here, is going to act like it has a set of lone pairs. And it's a really good nucleophile. Okay, so that's going to make the tack, you know, you're just going to do this one at a time. But there's actually this one here, this is the second one. Okay. So for these, right, so what you're doing is you're saying, okay, here's our leaving group, right? I told you it's an E2 mechanism. Okay, so what you need to do is you need to look on either side, okay, and say, okay, is there a hydrogen here? If there is, then there is a hydrogen here, so we can make a double bond there, right, which would be this one. Or if there's a hydrogen here, right, so we could put a double bond there. So you have to look on either side. Okay. For here, right, remember this is attacking there, pushing that away, right? So you can have two different options. Okay, oops. You can have the hydrogen go here and then the plus charge there, or you can have the hydrogen go here and the plus charge go there, right? So Br minus, right? If it goes there, right, we're going to make that product. If it goes there, it's going to make that product. Okay, so it's going to be, the HBr is going to add like this, or it's going to add like that. Okay. We're going to, I'm just looking for overall products. We'll talk about which one's more in later chapters. Okay, so for here, it's an SN2 reaction, so this whole thing is going to get replaced here. So this is the nucleophile. It has the negative charge, so it's a good indicator that's your nucleophile. This is we have a polar covalent bond here, right? Good leaving group. So this is going to attack there, kick the bromine away, and so you're going to get the fluorine plus Br minus. Okay, so for E2, right? So here's our leaving group, right? So we need to look here and here. Right, so we're going to get, if we rip the hydrogen away on this side, right, it's going to be that, right? If we rip it up on this side, it's going to be here, right? So this is where our leaving group originally was, right? So we're going to go on one side and the other because there's hydrogens on either side. Okay, now for here, right? This is where this metal is. The carbon metal bond here that makes this a lone pair, so I'm going to kick this up over here, down here. Now if we were going to collapse this back down, right, we have a carbon bond here, we'd have this new carbon bond, we also have a carbon bromine, so that's fine. So we can collapse down and kick that away, and so we end up with this here. This we can collapse down, this MgBr2, right? So we have this MgBr, and then it combines with this Br minus. There we go. Okay, to make the ketone. Okay, so you're going to have some of these predict the product questions. Now for the stereochemistry, right? So with here, right? Here's our leaving group. Here's our nucleophile with an SN2, right? We get inversion. Okay, so we're only going to get one product. So this is a wedge, so it becomes a dash plus Br minus. Okay, the same reaction, but we're on SN2. Remember, we get both. Okay, so we're going to get the original and the dash, like this. Oh, I'm sorry, not Br, OH plus Br minus. Okay, so there we go. So SN2 reactions, you get this. SN1, you get both. Now for the so for the E1 mechanisms, right, again, right, well here, right, so we'd look here and here, right, well this side doesn't have any hydrogens, but this side does, okay, and so what we're going to end up with is we're going to get it like this. So you have benzenes, that, you're going to have it like this, right, but then you're also going to have it like this. That plus Br minus. Okay, so you're going to hold one side fixed and have the double bond like this, and then the other side where it's flipped around. Okay, so like that. So now, last one is you're going to have this energy diagram, right? So with that, so you're going to need to do the reactants, products, transition states, and the intermediates. Okay, you're also going to need to circle which transition state would correspond to the overall activation energy. Okay, so first off, we're going to label these, right? So the reactants start here, the products are here. Okay, your intermediates are these sort of local minimum, so intermediate, and then the transition states are the humps. Okay. Now, the transition state that's going to correspond to the activation energy is the highest hump, so it's right here. Okay, the highest energy. That's what it is. So there you go. Good luck.